Hello and welcome to my video about multi-step equations and how to solve them. So on page 11 in your work text, if you have it handy, you're going to see some useful stuff here. To solve a multi-step equation, simplify each side of the equation. So you always want to simplify as much as possible before starting the solving process. Then use inverse operations to isolate the variable. Quick examples of inverse operations, the most popular ones that you'd have to deal with. If you have division, like x divided by 2 equals 3, the inverse operation would be to multiply by 2. So x would equal 6. If you have multiplication, like 2x equals 8, you would have to divide by 2 is your inverse operation, so x would equal 4. And then if you have any addition or subtraction, they cancel each other, vice versa. So if you have, for instance, x plus 7 equals 9, the inverse operation would be to subtract 7 on both sides, so x would equal 2. And if you had x minus something, you would add to both sides. All right, you can see worked out examples on that page 11, which are super cool. I'll leave you to see those if you need some more examples. Let's go ahead and get flying through these. I'm going to go to page, to the next page, which is on practice A, number 2, really quick. And I just confirmed that this is page 12, actually. So looking at this, what I'm going to do is use inverse operations. Now, also important to realize is that if you ever remember using order of operations, parentheses, exponents, multiply, divide, add, subtract, while you did start with parentheses and work your way down, when you're solving, you're actually going to do the inverse of that. So you're going to deal with anything that's being added or subtracted, work up to anything that's being multiplied or divided, and then you're going to wrap up with exponents and parentheses. So on this problem, to solve for z, I'm going to actually deal with the minus 13 first, because it's at the bottom of my list of operations. So plus 13 to both sides is my inverse operation. That leaves me with only 5z on the left-hand side, because minus 13 and plus 13 cancel, as they should have. Negative 3 plus 13 is 10. All right, now I have multiplication and division going on. I'm working my way up through the process. So I'm going to undo 5 times z. I'm going to divide by 5 on both sides. So z would then equal 10 divided by 5, which is 2. Moving right along. So as I said earlier, you should simplify both sides if possible. And here there are like terms to combine. So 15 would equal 2 plus 4 is 6 minus d. I've not done any inverse operations yet. I simply simplified by combining like terms. Now I'm going to deal with the fact that I have 6 minus d. What's going to happen is, since this 6 is actually positive, I'm going to subtract 6 from both sides to help isolate the variable. 15 minus 6 will be 9 equals, and 6 and negative 6 canceled, and negative d is what's left over here. Now you can think of that as being a negative 1 times d, and to help deal with that, we'll divide by negative 1 on both sides. So 9 divided by negative 1 is negative 9, and negative d divided by negative 1 is positive d. d is equal to negative 9. All right, so going on to number 6, you're going to have a fraction all of a sudden, which that implies that there's parentheses around this numerator. So we're actually going to save the q plus negative 5 to last. We're going to deal with the division first. So to cancel out the divide by 3, I'm going to multiply both sides by 3. So q, and I'm just going to write this as minus 5, is now equal to 8 times 3 is 24. You're going to notice that I dropped the parentheses that were around the q minus 5, and that was simply because there was no need for them anymore since I took care of the operation that was impacting them. All right, next up is to do what was in the parentheses. This will wrap it up, so I'm going to add 5 to both sides. So q is equal to 29. There we go. All right, going to go ahead and look at number 8, 10, and 14. So on number 8, we yet again have simplification that can happen. There are like terms of 5z minus 2z, which is going to create 3z minus 4 equals negative 7. So yet again, you're seeing this where we need to simplify if possible. Now I'm ready to do my inverse operations. Here I'm going to add 4 to both sides. So 3z is equal to negative 7 plus 4 is negative 3. And then after that, to cancel out the 3 multiplying the z, I'm going to divide by 3. So z is equal to negative 1. Taking a quick look at 10. Very similar problem, but the z's are not right beside each other, but that's fine. So 9z minus 4z is going to be 5z. And you still have the minus 5 here. Equals negative 5 over on the right-hand side of the equation. Now I'm ready to do the same thing that we've been doing, so you're probably pretty comfortable with that. I'm going to add 5 right there. So 5z is equal to 0. And then I'm going to divide by 5, and 0 divided by 5 is 0. So z is equal to 0. All right, on the last one for this lesson that I'm going over in this video, we're going to see yet again where we have to simplify one of the sides of the equation. So I'm going to have to actually use distributive property here with the positive 3. So I'm going to have 7 plus 3 times 2g is 6g, and 3 multiplies negative 6 to become negative 18 equals negative 29. All right, now what's up is I'm going to combine like terms again. So 7 minus 18 are the like terms I can combine. So I am going to still have 6g. 7 minus 18 is negative 11 equals negative 29. All right, now I'm ready for my inverse operations, which you should know well by now. So we're going to add 11 here. So 6g is equal to negative 18 and divide by 6 on both sides. So g is equal to negative 3. All right, that wraps it for this lesson. There is one more thing I just want to include really quick, and it's what to do whenever you have a negative distributing to something. So this is kind of like just a separate thought here. Whenever you have a negative distributing, make sure that you're distributing the negative. So 5 would still be here on this one. Negative 2 multiplies x to make negative 2x, and negative 2 multiplies negative 3 to make positive 6. So that's really important that you're getting that step right. The last thing you want to do is just mess up with your simplification before you get to actually using your inverse operations. All right, y'all, let me know if you need any helps. Thanks.